In this video, I'll be working out the section 12.2 notes. We're going to talk about general angle measurements and a new type of measurement as well called radian measurement. But before we get to that, let's talk about angles in standard position. In a coordinate plane, an angle can be formed by fixing one ray, called the initial side, and rotating the other part of the angle, the other ray, called the terminal side, about the vertex of the angle. So of course an angle is made up of a vertex and two rays, and an angle that is in standard position has its vertex at the origin of the Cartesian coordinate graph, and the initial side lies on the positive part of the x-axis. So this right here, if you have the vertex at the origin and one ray on the positive part of the x-axis, which we'll call the initial side of the angle, that angle is in standard position. And you can rotate that angle either counterclockwise or clockwise. And in this picture is being rotated counterclockwise. And the difference is important because if a measure of an angle is positive, then the terminal side is rotated counterclockwise. So you can kind of see here we have a positive angle that falls between 90 and 180 degrees. But if the if the terminal side is rotated clockwise, then the measurement of that angle is going to be negative. And there's a lot of things that we already know about this picture. In a Cartesian coordinate graph, we will consider this part of the graph to be 0 degrees because that's going to be the start or the initial part of the angle. And if I rotate it in this direction, we'll say that that's positive 90 degrees because it forms a right angle. And then another 90 degrees would be 180 degrees. And then 270 if we go one more quadrant. And as we finish that fourth quadrant, we get to 360 degrees, or basically one full circle. And we could keep going after 360. We would just have to keep adding. But in general, if you wanted a measurement of an angle, you could always measure it with a protractor as well. We're not going to be doing that, but you could do that if you wanted. We are talking about trigonometry in chapter 12, and of course trigonometry is the study of right triangles, which we will get back to in the next section. But with those right triangles, we talked about the acute angles that were in them. And you can almost see right here, as I have this terminal side drawn, if I just drop a side length down that is perpendicular to the x-axis, you can see a right triangle that is being formed. So a lot what we're going to see today is going to relate back to those right triangles that we saw in the previous video. Just more to come on that later. But as I mentioned at the top of the notes here, there is another way that you can measure angles rather than using degrees, and it is called radian measurement. And so if I go down pretty much to the middle of our notes here, I've got this little picture that I'll talk about in a moment. But degree and radian measure are just two different ways of measuring the same thing. Just like you could use the metric system or the English system to measure weight or to figure out height, degrees and radians are just different units to measure angles. We're familiar with degrees already, and everything is kind of based off this picture here inside with all these angle measurements. But radian measurement is a little bit different because radian measurement has a connection to arc length. And so this circle is drawn to kind of show you, and I could even use this circle right here and the angle that's drawn in. But radian measurement has a connection to arc length. And arc length, of course, is measured with pi involved. But if I look at this picture right here, I have my angle theta, and the angle is in standard position because its initial side is on the positive part of the x-axis. 1 radian, so we'll say that this angle measurement is exactly 1 radian long because the length of this terminal side as it hits this circle, whatever this measurement is, will be the exact same length as the intercepted arc length. So when you go to take pre-calculus next year, you'll get into a much more detailed unit on trigonometry, a much longer unit, and it'll talk about the connection to these arc lengths and these radian measurements. But just note that a radian is just a different unit of angle measurement that we're going to see in this chapter, It's used a lot in trigonometry. And a radian is connected to arc length in the fact that when I have exactly 1 radian for an angle, whatever this length is right here, it matches the length of this arc. The nice part about radians is you don't necessarily need that definition to answer some questions about its connection to degrees. So you can convert degrees to radians or radians to degrees, and the formula for converting is provided both here and here, depending on which direction that you want to go. But the most important part here is that this circle is provided for you to kind of show you the conversions on some angles already. For example, 90 degrees is pi over 2 radians. 180 degrees is exactly pi radians. And everything is in terms of pi because radians are all about the arc length, and arc length has to do with circles. Circles have to do with pi. So you're going to see pi involved in a lot of these radian measurements. And probably the most important 2 radian measurements are right here. 360 degrees, which is basically a full circle, is the same as 2 pi radian measurements, which then if you divide by 2, 180 degrees is equal to pi radians. And if you want to divide that by 2 again, you would get 90 degrees is equal to pi over 2 radians. So you can really convert anything, but these 2 right here are very important. You're going to use those more often than not. Same thing probably with the 90 degrees and the pi over 2. So if I want to take 315 degrees, which is actually right here, if I wanted to confirm that this is 7 pi over 4, I could just multiply by pi and then divide by 180. Now you're going to leave radians in terms of pi, so all you have to do is reduce the fraction 315 over 180, and I believe that does reduce down to 7 pi over 4. Both of those are reducible, and I believe that they're both reducible by 45. So if I take 315 and divide it by 45, it goes in there 7 times, and then 45 goes in 184 times. So I just reduced that fraction. Now technically I should write the word radians because that's the unit of measurement, but a lot of times it's left off. Same thing with part B. You could take negative 500, multiply it by pi, and then make sure you divide by 180. And so it's just something that needs to be reduced. So this is a negative angle, so it kind of goes clockwise, but negative 500 divided by 180, both of those are reducible by 20, I believe. So then this becomes negative 25 pi over 9. Yeah, that looks right. But you can do the reverse, right? So if I give you something that is in terms of radian measurements, you can convert them back to degrees by multiplying by 180 over pi. And the nice part here is since 1 pi is in the numerator and the other one is in the denominator, then you're going to cancel out. And I'll just use my calculator, and I'll take negative 14 times 180, which is negative 2,520, and just divide that by 15. And hey, it actually came out to be a nice measurement, negative 168 degrees. So part B, multiplying by 180 over pi to convert this to degrees. Pi's cancel, 5 times 180, it's going to be our measurement. That is 900 degrees. So we're going to come back to this circle here with some more specific information down the road in its connection to sine, cosine, and tangent. Eventually we'll learn about something called the unit circle, but we're not there yet. So the big part for today is knowing the degree measurements, which you're probably already familiar with the fact that there's 360 degrees in a circle. But the really important part is its connection to radians. And so I've started a couple things down here just because if you can kind of remember those, then they give you kind kind of some standard angle measurements, and then we'll get more into 30 degrees, 45 degrees, and 60 degrees down the line, because those are going to help us with some right triangles. All right, on the next page here, they have some practice of you drawing angles in standard position, okay? And so they have 240 degrees. So 240 degrees, the best way to figure out this drawing, so to speak, is to figure out which quadrant it's going to be in. So this is where the 90, the 180, or the 270 is going to come into play. So this is 0 degrees, this is 90, this is 180, and this is 270. So I know that 240, since it's positive, I'm going to move counterclockwise, and I know I'm going to go past 180 degrees, but I'm not going to hit 270, which is why the terminal side is drawn in right here. But the reason why this 60 degrees is added is because that's the difference when you go from 180 to 240, right? So if I take 240 minus 180, we get that 60 degrees, so it takes 60 degrees more to get to our final measurement of 240 degrees. And that 60 degrees is important because, as mentioned before, we'll talk a little bit more about that down the road as it kind of shows up, 60 degrees shows up on our circle. So just note that this is the initial side, and then this one right here is the terminal side. 500 degrees, that's way more than 360. So you can see that it's made at least one full rotation. So if you think about it, 500 is 360 degrees plus 140, which if you actually break that 140 up a little bit more, it's 360 plus 90 plus 50. So here's the 360. There it is right there. Okay, so just one full circle. And then I've got another 90 degrees. So then that will leave me, this little part right here should be exactly 50 degrees. So when they're asking you to draw an angle in standard position, knowing where its location is going to be at is good, but kind of knowing what components make up that angle, using the fact that there's 360 degrees in a full circle or 90 degrees in one quadrant, knowing kind of this smaller angle right here is going to be important for our upcoming sections as well. And then part C, I mean, this one's just a little bit different because it's a negative angle, so they have measured it clockwise. So if this is negative 50 degrees, then I also have another angle here that could be made up of 40 degrees, or I could convert that to radians as well, but we'll worry about that here in a second. But this one's pretty much already done for you. So let's go to part D, part E, and part F. Here they haven't drawn them in for us. So negative 5 pi over 3 radians. First thing I need to do is draw a XY chart. Next thing I'm going to do is I'm going to draw the initial side of the angle. Okay, this is always going to be the initial side because I always want to put it in standard position. Now I am negative, so I'm going to be going clockwise. And now I kind of have to figure out where I'm going to be located. And because this is in radians, if you want to take a moment and convert it to degrees, you certainly can. If you're not comfortable with radians quite yet, this would be a good way to do that. So let me go ahead and convert this to degrees. We are going to multiply by 180 over pi. And so the pi's are going to cancel. Negative 5 times 180, and then divided by 3 is negative 300 degrees. Okay, so now that I have this, it's not quite 360, but it's almost a full rotation. So it's probably going to look something like this. So I went 90, I went 180, I went 270. So then there's like 30 degrees left over, or negative 30 degrees, however you want to think about it, left over kind of in that spot right there. Part E, negative 400 degrees. So kind of same thing. I'm going to draw an angle that is going clockwise, and I'm going to do a full rotation for negative 360 degrees, and then I just need to add another negative, 40 degrees to get that going. So that's not going to be that far. So then this would be another negative 40 degrees right there. And then 6 pi. Six pi is the same thing as 2 pi times 3. And I mentioned earlier that 2 pi is an important number because 360 degrees is always equal to 2 pi. So essentially, I am just being rotated around this picture 3 different times. And it's positive, so I'm going to go 1, 2, 3. And then I'll just kind of draw an arrow to note that that's where that's going to end. The other part of this section, and then we'll see in the next video all the connections to sine, cosine, and tangent, but the other part of this video is finding coterminal angles. 2 or more angles that are in standard position with the same terminal side are called coterminal angles. So once again, 2 or more angles in standard position with the same terminal side are coterminal angles. It's basically, and I'll give you an example right here, 6 pi and 2 pi are coterminal angles because it's basically 1 more or 2 more or 3 more rotations of the same angle. So they ended at the same spot. So this would be 2 pi, and then I would have 4 pi, and then I would have 6 pi. Those are called coterminal angles because they share a coterminal side, or a terminal side. So all you have to do to find a coterminal angle is add 360 degrees to get a full rotation going counterclockwise, or subtract 360 degrees to get a full rotation going clockwise. And you can do that more than once, right? You can multiply it by 2 rotations or 3 rotations. And if you're using radians instead of using 360 degrees, you're going to use 2 pi. So if I have negative 45 degrees, find one positive and one negative angle that are coterminal angles with it. And they kind of already did the work right here because all you have to do is add 360 degrees to get that positive, or subtract 360 degrees to get the negative. Kind of similar manner here. 395 degrees is already more than 360. So here they subtracted 360 to get a positive number, and then they subtracted 360 again to get a negative number. So since our angle here in part B was already more than 360, instead of adding and subtracting 1 full rotation, they subtracted 1, and then they subtracted 2 full rotations. So down here, part A, okay, you can kind of imagine if I have an angle that is negative 70 degrees, I could add 360, and that would give me 290 degrees, or I could subtract 360, and that would give me negative 430 degrees. Like, it follows this first question quite a bit. 248, that's in between 0 and 360, so it's going to be the exact same thing. You are going to either add 360, or you're going to subtract 360. And once again, these would all have kind of the same terminal side, which you can kind of see here. If I go back to this picture, this one ends up right here, but then if I go 1 more full rotation in the other way, that one also ends up. So they're sharing this ray. That's what it means to be coterminal. Now, negative 7 pi over 6, you are either going to add or subtract some value of 2 pi. And it could be a multiple of 2 pi, so it could be 4 pi or 6 pi, kind of whatever works best for you. Same thing over here. You could add or subtract 2 pi. You could add or subtract 4 pi. Any multiple of 2 pi can be added or subtracted to find a coterminal angle. And that's why there's many and there's infinite solutions to these answers. So this just involves adding or subtracting 2 pi, and if you want to use a common denominator, you can. You can call it 8 pi over 4, or if you want to try to get a 6 as a denominator, whatever works best for you. Just note that you have to be a multiple of 2 pi. So I'm actually going to have to erase that so that way I can write down these answers. But I'll go ahead and just rewrite it up here. So you can add or subtract a multiple of 2 pi, whereas over here, if I'm talking about degrees, you could add or subtract a multiple of 360 degrees. Okay. So for part C, one thing that I could add, so 2 pi So 2 pi is the same thing as 12 pi over 6. Negative 7 pi plus 12 pi would be 5 pi over 6. And if I wanted to, then I could subtract those two. So negative 7 pi minus 12 pi is going to be negative 19 pi over 6. So those are two angles that are coterminal. And the other one would work very similar here. I need a denominator of 3. So let's see here. That would be 6 pi. So you could add those together, which would be 26 pi, though that's probably already positive. So I could subtract it, which would be 14 pi over 3. I could even subtract it again to get 8 pi over 3. Either of those would work, and that list kind of keeps going, right? You could subtract again to get 2 pi over 3. You could subtract again to get negative 4 pi over 3 until you find a positive and a negative angle, right? There's my negative angle right there, so that would be one of them that I wanted, and then any of these positive answers would work as well. So it's just all about this right here and this right here. Adding a multiple of either 360, subtracting a multiple of 360, or doing the same thing with 2 pi. And that's it for today.